Okay. So for the row operation, so this row operation is okay. I had written a row operation here, so it was not so correct. So I think this row operation is perfect for this linear system, for this matrix. So if you do R1 plus R2 and replace the value in row 2, you will get this row, and then if you do this row operation, so you will get the third row, okay? And then you can see you have a nice upper triangular matrix, right? Lower triangle, you have a nice lower triangular matrix. So this is our lower triangle, and so the result will be the multiplication of the main diagonal. So on multiply x, it will be x square. So we can say here x square, and then on the right side we had x minus 3, right? So x minus 3 into x squared. This is the determinant of our matrix. So guys, can you understand? We only did three row operation. This is the first row operation, this is the second row operation, and this is the third row operation. And I'm sorry if I did explain in wrong way, because I didn't I didn't write down the row operation before, right? So I just took the notes of our Lausi, and that's all. So that's why now I had to rethink like which row operation we did here. So these two are our row operation, okay? So I think you can understand them. Yeah, sure. Mitchell, you can say.
Okay, just wanted to say they said there's so many ways to get right, but I think to use this like formula of raw operation maybe it's too complicated rather than to use some other kind of
They are not
formulas,
complicated,
right?
okay? I will show you some example. They are not complicated. So this was a very fresh, this was a matrix, so we did it in a class, but I will start with a fresh matrix, okay? And then I will show you how easily we can get into RRF form, or how easily we can do row operation, okay? I will show you. It is not that much hard, okay? So I just need a paper, and I just need a paper and a pen, because you know writing with this mouse is terrible. So I will show you, okay? I will show you today. And if you have some difficulty, you can come here online, and then you can use these online calculators, okay? I have given you the link in the WeChat group. You can calculate RRF form, you can calculate inverse matrix form. There is a lot of option there.
Yeah, I wanted to say like
I'll show you, okay? I'll show you. Yeah, Michelle, tell me.
Yeah. Okay, I just wanted to say like maybe for us maybe it will be easier just to use another formula like the one that Lassie gave us, maybe those two formulas, rather than when it comes to questions like this, right? Uh, how about Jane? Maybe she's maybe she will understand this, but as for me, maybe it's hard when it comes to this question like this.
Oh, when it comes to row operation, it is hard, right? Okay, so I'll
Yeah,
explain. You can still use the online
especially to
calculator. So I suggest you can use both, okay? You can just check online for the result, and you can calculate with your own hand. So, and then you go back online and check the result if it is right or wrong. So I think that is the correct way. But if you are confused, then you can still use the online anytime, online calculator anytime. So let's see the next question, okay? I will explain. I will explain later. So can you go move to the next question here? Question number 5. So guys, can you hear me? So we have 4 vector here. We have 4 vector beta, alpha 1, alpha 2, and alpha 3. And then we have to determine whether the vector beta can be a linear combination of the vectors alpha 1, alpha 2, and alpha 3. If it can be, then write down the expression. So I have done this kind of problems in homework 5. Maybe okay, let me show you. Homework 5. Yeah, it is similar to this homework, I think. And let me also open the question, homework 5. So where is the question? Determine whether the vector beta can be a linear combination of the vectors alpha 1, alpha 2, and alpha 3. Yeah, it is similar to this question, okay? So determine whether the vector beta can be a linear combination of alpha 1, alpha 2, and alpha 3, and if it can be, write down the expressions. So number 2 and the first question, okay? Homework 5, number 2, and the first question here, okay? So if you see here in this example, so if beta is a linear combination of alpha 1, alpha 2, alpha 3, then we can write down this way: beta is equal to x1 alpha 1 plus x2 alpha 2 plus x3 alpha 3, okay? And then we have to write down the augmented matrix. So if you look here in the homework 5, so we have the beta, we have alpha 1 here. So we have to start from alpha 1, okay? You see, we have to start from alpha, okay? We have to start from alpha 1, and then alpha 2, alpha 3, and then beta. And you have to find the transpose matrix. So it will be this way: -1, and then 3, and then 0, and 5, okay? So this way we find the transpose matrix. -1, 3, 0, 5. So you write down here, okay? -1, 3, 0, 5. And the same way, here is alpha 2, here is alpha 2, here is alpha 3, and here is our beta, okay? Here is alpha 1. So guys, I think you understand this part. So I have just written alpha 1, alpha 2, alpha 3, and beta here in a augmented matrix form, okay? And then you have to make it RREF. So if you make it RREF, and then see if so if you look here is alpha 1, right? Alpha 2, alpha 3, and beta. So this beta, it should stay on the right side of the equation, okay? It should stay on the right side of the equation. So if you look here, we have alpha 1 here, right? So alpha 1, and on the right side we have 0. So alpha 1 is equal to 0. And then we have alpha 2 here, right? Alpha 2. So alpha 2 is on the right side, we have, so alpha 2 equal to, on the right side we have also 0, right? So alpha 2 is equal to 0. And then we have alpha 3 here, right? Alpha 3. So alpha 3 is equal to, on the right side we have 0. So alpha 3 is equal to also 0. But here there is no alpha, so here this is 0 is equal to 1, right? If you see the last row, so all the entries are 0. So here 0 is equal to 1. So we know that 0 is equal to 1, it is not true. So there will be no solution. So that's why if there is no solution, so beta is not a linear combination of alpha 1, alpha 2, and alpha 3. But if there is a solution, then beta is the linear combination of alpha 1, alpha 2, and alpha 3. Okay, guys? So the same way we can do, so let's see if we have another same kind of question or not. So for the test paper, so we also need to write down the related augmented matrix. Okay, let me calculate it from the very beginning. So yeah, so we have we have alpha 1 minus 1 3 0 5. So let me write down. I'm doing from scratch. Okay, I'm doing from the beginning. Alpha 1 is minus 1 3 0 5. So minus 1 3 0 and 5. Then alpha 2 is 2 0 7 minus 3. 2 0 7 minus 3. Then alpha 3 is minus 4 1 2 minus 4 on minus 2 6. Minus 4 1 minus 2 6. And then beta is 8 3 minus 1 minus 25. 8 3 minus 1 and then minus 25. Okay, so now we have to convert this this augmented matrix into RREF. So either you can use online calculator, or okay, let me firstly take the online calculator and then I will show you the procedure. Okay, like how we can do it manually. I think I should use Google Chrome right now. Okay. So if I search are reduced, yeah, so here we have reduced row echelon form, RF calculator. And then it is our matrix is, it is 1 2 3 4. 1 2 3 4 1 2 3 4. It is a 4 by 4 matrix, right? So let's calculate here. It is a 4 by 4 matrix, and then I have to put the value. So alpha 1 is minus 1 3 0 5 minus 1 3 0 5 minus 1 3 0 5, and then 207 minus 3, 207 minus 3, and then minus 4 on minus 2 6, minus 4 1 minus 2 6, and then beta, right? So 8 3 minus 1 minus 25, 8 3 minus 1 minus 25, minus 1 305, 207 minus 3, okay, minus 4 on 2 minus 2 6, minus 1. So now we click here calculate, and then we will find the RRF form. So you see here, this is the RRF form, right? So it is a 4x4 in identity matrix. Maybe we could get something else, but for this particular matrix, our solution is a 4x4 identity matrix. So if I write down here, okay, so the RRF form, if we do the reduced row echelon form, so it will become a identity matrix. It is not necessary that all the time it will be a identity matrix. So just for this case, it has become a 4x4 identity matrix. Okay. And now if you try to calculate, so if you try to calculate the, I mean, our question is, whether the vector beta can be a linear combination of the vectors alpha 1, alpha 2, and alpha 3. Okay. So if you see here, we have alpha 1 here, right? Alpha 1 and alpha 2 here, alpha 3 here, and beta here, right? So if I write down the result, it will be alpha 1 is equal to, okay, let me just draw this line. So alpha 1 equal to, okay, it will be alpha 1 is equal to 0, and then alpha 2 is equal to 0, and then alpha 3 is equal to 0, and and the last line we will get 0 is equal to 1, right? So as here 0 equal to 1, this is not true. So this linear system, so we can say that beta cannot be a linear combination of vector alpha 1, alpha 2, and alpha 3, because here the fourth on the fourth row, this condition is not true. So that's why we can say like this is not this beta cannot be a linear combination of the vectors alpha 1, alpha 2, and alpha 3. Okay, guys.
Yeah.
It would be great if I could show you some kind of case where beta can be a linear combination of alpha 1, alpha 2, and alpha 3. So I will try to find those kind of question. So, but before that, let's finish this part, number 6 and number 7, okay? And then we will talk about that one. So number 6, we have assumed that the group of vectors alpha 1, alpha 2, and alpha 3. We have to find the rank of this matrix, okay? So firstly, you have to write down the transpose matrix, and then you have to make it to you have to reduce the row. So maybe I have written the answer here. No, not here. So Laoshi also didn't, because we did the same types of problem in homework 5. So let me show you here. The question is find the rank of A, right? So to find the rank of a matrix, we have to reduce the row, or we have to make it to RREF. And then, okay, where is that homeworks? Maybe in homework 3. Let's see. Homework 3. Not here, maybe in homework 4. Yeah, so look here. So for homework 4, we have some kind of problem like this is the question. We have similar kind of problem, okay? So number 4, calculate the rank of the following matrix. So this is a 3 by 4 matrix, right? 1, 2, 3, and 1, 2, 3, 4. This is a 3 by 4 matrix. So I have written the matrix here, and then I have converted, I have done row operation, and the last line I got a, I mean, this is not RREF, but this is only REF, okay? Reduced echelon form. It is not RREF, it is just REF. So to find the rank, REF is enough, okay? So now we have to look at the first non-zero entries of each column. So if you see here, we have first non-zero entries here, and first non-zero entries here. So and the last row, all the entries they are 0, right? So we can say that the rank of this matrix it is 2, right? 1 and 2, because we have only 2 non-zero entries here. Guys, can you understand? And let's solve this equation like the test paper. So we have alpha 1, alpha 2, and alpha 3. So we can use our online calculator, right? So alpha 1 is on 2 minus 1 5. So let's see here. It is a so if I write down the corresponding matrix, it will be 1, 2, minus 1, and 5. So I am just taking the transpose, okay? So alpha 1 is here, 1, 2, minus 1, 5, and then alpha 2 is 2, minus 1, then 1 and 1. Alpha 3 is 4, 3, minus 1, and 11. So it is a 4 by 3 matrix, right? It is a 4 by 3 matrix. So now let's find the rank. 4 by 3 matrix. And entries are 1, 2, 4. Okay. 1, 2, 4. And then we have 2 minus 1, 3. 2 minus 1, 3. Then we have minus 1, 1, minus 1, minus 1, 1, minus 1. Then 5, 1, 11. 5, 1, 11. So now let's calculate. You can see the detailed row operation here, okay? R2 equal to R2 minus 2 into R1. So we just go to the last line, and this is our RREF form, right? So on 0, 2, 0, 1, 1. So if we do the row operation, we will get 1, 0, 2, and then 0, 0, 1, 1, and then 0, 0, 0, and then 0, 0, 0. So guys, can you tell me the rank? Can you tell me the rank of this matrix? So here is the first non-zero entry, and here is the first non-zero entry, right? And so we can say that the rank of this matrix is 2. Okay, as you see here. Okay, right. So this way we find the rank. Like firstly, we convert this equation. We convert this equation to we do row operation, and then we convert this equation to RREF form, and then we count the non-zero entries of each column. So here we have 2 non-zero entries, right, or 2 pivot point. So this matrix, the rank of this matrix is 2. Okay, so rank of this matrix is 2.
Oh,
And then the second question here. So Jem, can you understand?
okay.
Hello, Jem. So the second question is determine linearly independent or so determine if A is linearly independent or linearly dependent. So we have similar kind of problem here in the homework 5. So you see here number 3, determine whether the following vectors are linearly independent. So the same question here. So determine linearly independent or linearly dependent. So if you look here, so we have to write down the corresponding matrix here, and then we have to write down a column that all the entries containing 0. Okay. So if you look here, we have alpha 1, alpha 2, and alpha 3, right? So we have written so here we have written alpha 1, alpha 2, and alpha 3, and for the last column we have written all the entries 0. Okay, it means if it is linearly independent, then the last column, so all the entries of this last column will be 0, and then you perform the row operation and you will get this matrix. So you see here, we have on the last line we have a free variable, right? Because all the entries of here it is 0. So we can say like x1, x2, and x3, they are basic variable, but this last one it is free variable, right? Because here is 0 equal to 0. So 0 equal to 0 have so many possibilities. Okay, let me show you. I can say like 2 multiply 0, it is 0, right? I can say 3 multiply 0, it is also 0. So this way it has a lot of choice. So we can say that this x4 it is a free variable. So that's why, so I write down this way. So it is x1 equal to 0, and x2 is equal to 0. If I write down that diagonal, that line here, so it is x1 x2, and then x3, and it is our like so we can also say alpha 1, alpha 2, and alpha 3, alpha 1, alpha 2, alpha 3, and then this is beta, right? So you can say like alpha 1 is equal to 0, alpha 2 is equal to 0, alpha 3 is equal to 0, but for the last row it is 0 equal to 0, right? That means it has a lot of solution. So x4 is free. So since we have more than just the trivial solution, that means since we have a lot of solution, so vectors are linearly dependent. So if there is more than one solution, or more than just the trivial solution, so the vector will be linearly dependent. Maybe yesterday I told some kind of tricks. That means, so let me write down the tricks again here. So if you are single, for example, you are single, right? That means you are not yet married. So you have a lot of choice to choose your husband or choose your wife. So lot of choice. So that means, and also you are dependent with your parents, right? Because you don't still you don't earn money. So you are dependent on your parents, and then your rank, right? Your rank is lower than other other family members. So your rank, I mean rank of the matrix, it is lower than number of row. Okay, it is lower than number of column. It is lower than number of column. So I mean rank of A is lower than number of column. That means, so if you look here, so you have to remember these three things. Okay, like this equation will be dependent if the rank is lower than the number of column, and there will be a lot of solution, or you will have a lot of choice. That means there will be a lot of solution. Okay, so as you see here in this RREF form, so here the rank of this matrix is you can see the rank of this matrix is 3, right? Here the rank of this matrix is 3, and here the number of column is 1, 2, 3, and 4. So you can see that the rank of this matrix, it is lower than the number of column, right? So that's why we can say this linear system is dependent. Okay, this linear system is dependent. So guys, can you understand now? I mean, can you just remember those things?
Yeah, got it.
Okay.
Got it.
Jem? Hello?
Yeah, I understand.
Okay. And then, so the same thing will happen for the test paper, okay? I mean, the same thing will happen for, what is that? Yeah, the same thing will happen for this question, okay? Determine whether, determine linearly independent or linearly dependent. And number 3, find the maximal subset of the independent vectors of A. So we already did in the previous homework. So in homework 5, find the maximal subset of independent vectors. So the answer will be same as homework 4. Will be same as number 4 question of homework 5. So yesterday maybe I explained this, not yesterday, maybe yeah, yesterday, right? Yesterday I explained this one. So you can see the previous video, okay? So let me just let me just explain within 1 or 2 minutes. So again, we have alpha 1, alpha 2, alpha 3, and alpha 4, right? And we have to calculate the rank of this vector, and we have to find the maximum subset of independent vectors. So number 4 is here, okay? So again, we write down alpha 1, alpha 2, and alpha 3, and alpha 4, as we have this four equation. I mean this four matrix: alpha 1, alpha 2, alpha 3, and alpha 4. So okay. So I have written here, okay, alpha 1, alpha 2, alpha 3, and alpha 4, and I have reduced the row, and I got this one. So this is our RAF form, and if you look here, so the rank is 1, 2, 3, right? So the rank is 3. So the rank is 3, and then the maximum subset of independent vector is alpha 1, alpha 2, and alpha 3. So maximum subsets are here. Like if you just skip this row, because they all of the entries, they are containing 0. So if you skip this row, you will get the first row, the second row, and the third row, right? So for this reason, our maximal subset for the independent vector is alpha 1, alpha 2, and alpha 3, okay? Not the alpha 4. And let's see the last question here. So we have to find the eigenvalues, right? So the formula is absolute value of a minus lambda I is equal to 0, okay? So that means lambda I means, for example, this is a 3 by 3 matrix, right? So lambda I will be this way. So we write down lambda here on the main diagonal, and then all the entries will be 0, okay? Oh, sorry. So this is lambda I, okay? I mean, there was identity matrix, and then you just multiply lambda with that identity matrix. So you got this one. So a minus lambda I, it will be this way, like on minus lambda, and then here on minus lambda, and then minus on minus lambda. Okay, guys, you just minus lambda with the main diagonal. So then you will find the equation. So you see here in my notes, I have written here, like, so our matrix. So I have written minus lambda here, and also minus lambda here. Okay, and then you expand this. Okay, I mean, if you just take the first entries, if you take the first entry here, so you have to skip the row and the column, and then you will get this part, right? So I have written here, this part here, and then as I have taken on minus lambda, so I have taken on minus lambda here, and then it will be minus. So you can just imagine this way: it will be plus, it will be minus, and it will be plus. So all this part, this part, it will be minus. Okay, you can just memorize, so you don't need to write down all this part. So this part means minus.